tomorrow I'm out for installment number 2 of the meeting that I went to like almost a month ago, trying to make this new assessment thing for the district, which is good because we have a voice from like every middle school there, so they're trying to make sure that every school is represented. But this is going to be your top priority tomorrow, which is the mini mastery that I had contemplated us taking today. By the way, algebra tiles, sorry I don't have those out, but we need algebra tiles, so I'm surprised nobody said anything about it. We got them there, and then this box over here. So here in a second, once we make announcements, okay, grab your algebra tiles. You need like 2 bags per group. Don't grab a bag for everyone, just do like 2 bags per group.
I like how I put my pencil down and then it disappears.
Like that? Like when my screen disappears?
Like it grew legs and then it ran away. Oh my
Alright, so check it. Tomorrow, when you come in here, and hopefully Mr. Smith will be here, a few things are going to happen. One, you're going to have a mini mastery to take that is 6 questions. That's it. Here are the questions, so you probably want to listen right now. Number 1, calculate the unit price of a sale that I got on Black Friday. This is like real, I wrote this mastery, all of these problems. I am sad because it's getting harder and harder to disc golf. So, yeah, we got to check. This is all about disc golf. So, for real, I got a deal on Black Friday and I ordered a set of 10 discs. You calculate the unit price of what I paid per disc. Then, in number 2, you got to define what does unit rate or unit price mean. So if you right now couldn't tell me what a unit rate or unit price is, like pull it out of your own head, you need to figure that out before tomorrow. Right? That's question 2 on the quiz. Number 3 says using what you calculated from unit 1, figure out, or sorry, number 1 is actually just figure out the total because I paid for the discs and tax and shipping. So you just essentially have to add it up. Number 3 is calculate the unit price. Number 4 is make a table using that unit price. And there's a little bit more details to it, but that's it. So the whole front is just essentially unit price, unit rate. The back then is another unit rate problem and then graph it. So you have a 10 by 10 grid on the quiz. You will be asked to set the scale of what scale are you going to need going for x-axis and y-axis, and then graph it. Put your points in the line, and you guys know how proportional relationship graphs work. That's it. Then, hopefully, if Mr. Smith is here and is able to do this, your masteries will come back to you. Like while you're taking the mini mastery, you'll get your other masteries back. So the rest of your time during the class can be either revising your mastery, like correcting it, or working on homework. Today, we're going to end up in lesson 432, but your homework is still just 431. Your homework for 432 is technically tomorrow's assignment because you're not going to do a new lesson tomorrow. So we're going to finish 431 today and do 432, but like that's how I split out the homeworks. So still today's assignment 431, and then tomorrow's. You can do both tonight. If you want to get them done, just do 431 and 432. Very similar content. So any questions about today, tomorrow, what's happening, how to play disc golf? Mr. Smith, you'll notice my mini mastery is all about disc golf because I'm sad. Alright, so you do not have to pull these out of your bag, but right now, if you look at this collection of tiles, actually I'm going to move it so you can only see those. Take a moment, refresh your brain from yesterday, and on your paper, this is 471, so you can actually be using the same notes as yesterday if you want, or you can be in new notes, but if you want to label that this is 471, what do we have up there shown right now when we write it with like terms put together? So don't say like an x, another 2 x's, another x, a 2, like put your like terms together. So take a moment. On your paper, write what we have up there. An expression is actually what it'd be called. We won't use an equal sign. Yeah, so it would be an equation if we use an equal sign. Yeah, so because we don't know what x equals, we don't know what this together equals. Sorry, it's up on the TV now. You can still see all of it, but I wanted somewhere to write. We're going to use a lot of random cards today. So today, especially, if you don't know what you're doing, just lean over to a neighbor and be like, hey, help. All right. Skylar. Sky had her hand up, and I told her to put her hand down, and then her card ended up on top. Skylar, what do we have up there, and why?
I wrote down x squared plus 6x plus 8.
X squared plus 6x plus 8. Okay, how'd you get that?
Because you have one x squared box, I know that there's only going to be one.
So why don't I have a 1 out here?
Because you don't need to.
Ah, we don't need it. We could put a 1 there, but we don't need it. Continue.
And then I counted all the like plain x's, like x things, and there are 6 of them.
Yeah,
And
1.
There are 6, and we don't know the value of them. We just put 6x.
Yeah, love it.
And then there's a 5, and then 3 ones, and I just know 5 plus 3 is 8.
Perfect. Any questions on how Skylar got what she got? X squared, 6x's, and 8, because we put all the same tiles together and then count them up together. Any questions on that? You should have textbooks out, so go ahead and look at 72. We're doing the same thing. First thing we're going to do is areas. So we're doing the same thing. Then we'll move to perimeter. But so if you want to get out the tiles, get them out, or you can just look here. Actually, this might be an easier view. Here's what we have. I don't know which would be easier.
Wait, is this one the x squared, or is that the smaller one?
The smaller square, the blue square, is the x squared. But it actually, the only reason it matters is that the blues line up with each other. That the x lines up with x squared. If I make the purple square x squared, then my longer like purple rectangle, that would just have to be the x tile. Like I could change it, but for what we call them just as a class together, we just made that choice. But again, because it's a variable, we don't really know. Nora, what would help me? Like this is an E tool up here. What would help me be able to like talk about this easier? Yeah, but like so I guess this in Desmos, you have like all of the freedom, like you are in total control, kind of like whatever video games you guys have. So like I can move these. I'm probably just asking the question poorly. Would it help us to like shift things around a little bit?
Yes, kind of.
So Nora, if I go to shift this, what should I be doing? What shifting should I be doing? We are grouping our like terms. That's what we're doing either mentally or physically. We want to group our like terms. So I'm going to bring my x squareds all into the same area. I'm going to bring my x's all into the same area. And my constants all, I hate that that doesn't group. So in Desmos, if you go to use Desmos, by the way, a 5 tile is broken up into 5 singles. You just have to group it, and then you can drag the 5 together. So if you slide, like with your mouse cursor, like you click and drag, you can group everything together. X, another X. So when I look at this in total, Natalie, what do we have up here? 3x squared plus how many x's? 6 x's. And how many constants? 18. I would agree with that. Any questions how we got that?
Well, I didn't know, but is it okay if I put x squared plus x squared plus x squared?
It's okay, but it's not simplified. So that's actually a fantastic question. Guys, we are to the point in the year where if it says simplify, or even if it says like solve, you need to put it in simplest terms. So while what Ava just said is right, it wouldn't get full credit. Like I would have her go back to it. I would probably just write on there simplify or keep going. because she asked, if you didn't hear, could I write x squared plus x squared plus x squared? So think about how much easier it is to say 3x squared plus 6x plus 18, instead of saying x squared plus x squared plus x squared plus x plus x plus x plus x plus x plus x plus a 5 tile plus a 5 tile plus another 5 tile, and then a 1, a 1, a 1. That's why we don't do that. That's why I like math, because we don't do the nonsense stuff, right? We want to be as easy, as straightforward, as simplified as possible. That make sense? Yeah, Aiden? Makes sense?
My mom didn't like common.
Well, they didn't learn.
That's a really broad statement that we don't need to get into right now. All right, in B, find, yeah, actually just go ahead with B and C. Find the area again. B and C, just find the area again. Then we'll move our skills forward.
That was fun.
You think you've already mastered this skill. The next thing we're going to is perimeter.
Oh, no.
Yeah. Right when you think you got it. All right. Jalen, what is my area for B? Just area. Okay. So what do you got for B? X squared plus x plus 2. And C, take a moment if you need a moment. It's pretty straightforward. Isaac, what do you got for C? 3x plus 3. Are we all comfortable with how we're getting these area expressions?
Yes.
Because this just has 3 x's that we can group together and 3 constants. Now, if you look at 73, I'm going to give you guys a few minutes. Actually, scratch that. I think we're going to skip 73. No, what do you mean no?
Skip it.
Because 85 is the same thing. Well, not quite the same. It's missing one little piece.
We could probably add it.
So let's do this real quick, I guess. You don't have to write anything down. Trying to make your life easy. All right, so if we looked at 73, and Ava, this is like directly to your question. So Leanna wrote the perimeter expression for 73 part C as 2x plus 1 plus 1 plus 1 plus 2x plus 1. That is not simplified. But let's check what it would actually be.
Oh, wait.
What's the length on this edge right here? X. And here, and then here,
1.
1.
Okay, well, I'm gonna skip somebody problems.
And I'm trying to like get through stuff, and it's all the same content. This is the next problem. This is 73. And then x, 1. So I collect my like terms. Do I have any x squareds?
No.
No, because we're not talking about area. You know what it is?
4x plus 4.
Combined, we have 4 x's, and then we have 1, 2, 3, and another 1 down there. 4x plus 4
I was
plus
like,
1.
this is gonna be so hard, but it wasn't even hard. Okay, yeah.
Hang on
it's
to
not
that.
hard.
Just be
It's not hard.
careful. You're making big statements. All right, so we're going to jump over to 432. So flip in your books a couple pages. And we're going to be looking at 85. So if you want to go ahead and throw a new label on your notes, this lesson is going to start. This lesson is going to start to get us into the distributive property. So if you want to throw a label on your notes, either draw a squiggly line or something. 432. Distributive. And then right beside that, just so you have like an indicator right there, either like just to the right of this if you got space or just below it. Distributive property is when we have something that looks like this. And the key to it, guys, you will learn this Well, if you do one simple thing, draw arrows.
No.
What?
I guess you could say that.
Well, it's a U, but my handwriting's just sloppy. So my U does this, but when I go fast, it does this and looks more like, you know what I mean? Like I was just going fast. So I get how it looks the same. So, distributive property, that. Please draw that on your paper. It will save you so much time and hassle and struggle and tears and anguish.
Oh, I
You
get
just
so
draw
angry
the
right now.
arrows. Because we're going to cycle back to this in like a little bit, but I'm just going to show you this real quick. Each arrow shows me what to do. The first arrow, the little guy, does 2 times x, and I get 2x. The next arrow, the bigger guy, gives me 2 times 2 and gives me 4. That's a distributive property. Period. Done. That's
Oh
it.
my gosh.
That's it.
So easy.
And it's right there.
Kiss your friend.
So if you forget it, it's right there on that purple poster. But they use all variables. So I tried to make it a little bit easier up here and use a couple numbers. I should have probably not used 2 twice, but all right. So we're gonna cycle back to distributive property. Hey guys, if you are just playing with the tiles, please stop. Like we're in 7th grade. I should be able to trust you with a manipulative without thinking like they're gonna build houses with it or what. Like, just stop. Come on, we're in 7th grade.
You're able to build houses with them?
I'm just making stuff up, but yeah, you could 2-dimensionally design whatever you want on the table. You can play with these, just not during class. Grab them at AO or extensions or whatever.
Well, I found out that too. Why?
So let's go ahead and put the tiles away. Just rebag your tiles. Sorry to burst your bubble, but it's just too much of a distraction. Take a moment, rebag all your tiles.
What problem is this?
We're on 85 now.
We're already on 85.
What's the next lesson? We went from one lesson to the next. The announcement I was making at the beginning of class that you probably weren't tuned in to.
No, I listened that you said we're going to go from 431 to 432 and we're going to do all of it. I listened to that part, but I didn't know it would be like from like 440 something, maybe 470 something. Oh.
It's an entire lesson.
I thought
done.
it was 440 something. Sorry. I'm We're zooming through these things. We're like, damn.
All right, so if you're still putting away, please wrap that up. But then, now, I had some people tell me this was really easy, so be careful as you go do this. In your book, or up here, if you can see a couple, or you might be able to see all 3. Find the perimeter of these 3 shapes, and if you want to go the extra step, do area and perimeter, just to test yourself, because that's what we're going to do up here. Actually, just go ahead and do area and perimeter, because I want to go to random call on people for this. So just everybody do area and perimeter for all 3 of these. This is number 85.
Wait, so don't we have to draw the shape to do perimeter?
No, you do not have to draw the whole thing, especially if you have a book in front of you.
Yeah.
You don't have to draw it. If you want to really quickly to help you out, that's fine, but do not trace, like do not spend a bunch of time on it.
Yeah, but don't we have to, then how do we get the perimeter?
Add up all the values going around. So Ava, what is this length right here?
X.
So I've got 1x there. What about up here? 1's all the way around, right? This length?
X squared.
Well, but the length isn't, the tile's x squared, but the length is only x. So then we know also down here. And what is this?
1.
And over here? Over here?
X.
And then another. So now you just group your x's with each other and your constants with each other. Mm-hmm.
Oh, 8 plus 4. Oh, that's 4x.
So we're going to call this one Ava's problem then, because she went ahead and worked through it out loud for all of us. But then I'm going to give you a little bit of time. As Ava showed, what we want to do up here is figure out the lengths of the edges for each section, then go count up and group my like terms together. So our perimeter up here, we had 4 x's and 8 for my constant length. the area of that tile set. Anybody?
The area?
Yeah, of this tile set.
1x squared,
Uh-huh.
2x plus 2.
Absolutely. So keep going on B and C. If you need help, please stick up a hand. Happy to come help you.
Oh, I got it.
It's the same tiles.
Yeah. Oh, wait, yes, this is the same.
So the question becomes,
No, the perimeter is the same.
that's two different things.
Oh, yeah, 7, 8. 1, 2, 3, 4. That's the same perimeter. Why are they all the same?
Do you have perimeter and area going on there? You just don't have them labeled, which is perimeter and which is area. Guys, please label P for perimeter or A for area. Like, please make sure that you know what's going on.
Bro, I could have just looked at the first one and then not take the second one. I know, bro. And then 7, 8. I mean, and we are in the exact same shape.
Oh, I got A, B, and C.
All done. Area and perimeter both for all of them. All right, random cards. Brendan, do you want to do area or perimeter for B?
I'll do both.
Okay. Give me the area.
For what B? B is 2 plus 2x plus x squared.
I agree 100%, but in math we tend to put the variables first and the higher power variable first. So while what you said is totally right, I'm going to rearrange the order, right? Commutative property, rearrange the order to x squared plus 2x plus 2, which we'll also notice is the same area as what we had in A. Now, Layla Sky, I'm going to come to Layla because you guys were arguing. Will the perimeter be the same here?
Yeah.
No.
I thought you were the one who told me it wasn't going to be the same.
Yeah, and Skylar convinced me that it was.
No.
So, Brendan, you said you wanted to do both. What'd you get for the perimeter here?
8 plus 4x.
So again, I'm going to switch that order around and do 4x plus 8. So if I have x, 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 right, there's my 4 x's. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that's right. We get the same area and the same perimeter.
That's not the same thing as the perimeter, though. It's not laid out the same. It's not laid out.
No, what does it say? Exactly the same as
So this is a great argument. I love that we're having this argument. Now hold on. Order in the court. Calm down. What are we gonna do if I call him? Aiden, say what you said. I'm gonna come to you, Jaden.
Technically, that, and I don't think that's like the same because 4x plus 8. How was that the same?
Oh,
Didn't we have 4x plus 8 up there?
Oh, I thought you meant as the area for.
No, for perimeter.
Oh, I was.
That's
like,
why
so
we
confused. I
label
thought you
area
guys-
versus
Oh.
perimeter. So Jalen, what
I
were
was
you gonna
like,
say?
this is not the same.
It's the same because in A there's 1 x squared, there's 2 x's, and there's 2 1 things.
Yeah.
And it's the same. That's the same tiles in B, but it's arranged differently.
Okay, I got a question.
Wait.
Do we have to have the same tiles to get the same perimeter?
No.
Now, why did somebody of you say no at the
Yes,
same
yes.
time, Riley?
Because they have to be organized a certain way. Because if the one square were like right next to each other, then it wouldn't be the same amount.
Oh, how we organize it is going to change what we have. So if we look at C, Nathan, did you get to C yet? Okay, take a moment and do C if you haven't done that yet, guys. Perimeter and area.
I've done it.
Now, most of us, we can probably see the area is different because we're missing something, right? What don't we have in C?
The x squared.
The x squared. So we still have the 2 x's.
Plus 3.
And we now we have 3.
Now perimeter is 8 plus 4.
Hold on. For perimeter, you're going to come back to on another one. Start to group things. But, wait. I bet you there's a much easier way to really think about this. What shape do we have in C? Combined.
Rectangle.
One big rectangle. What are the end lengths? 1s, right? So I immediately have 2 from those end lengths. But then, the top and bottom are the same, right? So I could say double, what's my top length? 3 and, 2x plus 3, because that's the top and bottom.
This is more complicated than what I did.
Yeah, I don't like complicated stuff.
I'm just tying together the idea of today's lesson. You don't have to do it that way.
Oh, okay.
If I have complicated things, I'm just going to clear this and move stuff. I could just say I have double, and this is going to be perimeter for C, double my 2 x's on top, my 3 on top, and my 1 on the end. Well, really, I could group my 3 and my 1. But I could represent this whole thing by just saying double some quantity. Right? Now, we could just walk around and collect things and say, okay, x, 4 x's, and 3 on every end. Right? 1, 2, 3, 1, 2, 3. Ooh.
Oh my god.
It's the same perimeter.
OMG, boys.
But guys, we're missing an x squared. How's it the same perimeter?
Because it's organized.
It's laid out differently.
Oh my gosh, that's annoying.
So that is so magical. Beautiful.
No,
Yeah.
mine is not beautiful.
It is.
No.
Be careful stating opinions.
Diamonds are
Guys.
beautiful. Diamonds are more beautiful.
No, they're not. Diamonds think they're so great. What's the
All right, so here's what we were talking about yesterday. X is Stretch Armstrong, right? So think back to the idea that X is Stretch Armstrong, right? He can shrink down smaller than it looks. He can stretch out bigger than it looks. So if we think back to what we just had for 85, so hopefully you have this work written out, and we then get told what X is. So now we're just going to talk about perimeter. And no, apparently we're going to do perimeter and area. If we go back up here with X being 6. So first, I'm going to give you a couple minutes to go up there and do this. Go back to A and think about if X was 6, what would X squared be? What would those dimensions be? What's our new area and perimeter? And do that for A, B, and C. Now, if you have it written out, you could just plug in X is 6. Just stick it in your equation. So we're now going back here and resolving these, knowing that X is actually 6. Like the length of X is actually 6. All right, let's do X plus X squared. I like how your color is back here. Activates your brain better.
I lost all my pens. Oh, my look at the beginning of my mouse. That was all right up.
But the area is not the same in C.
Oh, 12. I'm confused. Oh, that's.
All right, Nathan, I'll come back to you for this one. If we have edge lengths of 6, what's the area of the square in the middle? Careful, what's 6 times 6? 36, right? So if I have 6 on the bottom and 6 vertically, the middle square is 36. So that's the area of that. Adrian, if our x is 6 and we look at the x rectangles, what's the area in one of the x rectangles? The area is also 6. So I'm going to circle my area values in here. And then we know the areas up here are 1s. What's our new combined area? Anybody?
Oh, 50.
Wow, what confidence in there. What's our area? 50. If you had this written out, we have 36 in the middle, 2 different 6s, and then 2 1s on top.
That makes no sense.
Okay, Aiden, why?
Because why would you so we had to be x.
No, why does it make no sense?
Because like I don't know how you got 36.
Hey guys, we got a lot of side conversations. You need to stop. So this middle shape, let me erase this and come back here. So Aiden, this middle shape right here is the what tile? What do we call it? The x squared tile, right? Because it is x by x. It is a square with length x, height x. We then get told, well, x is actually 6. So now we have a square, length 6, height 6. What's going to be the area?
So 6 times 6 is 36.
It's a 6 by 6 square. But then the rectangles on the edges are not x by x. They're x by 1. So they're 6 tall and 1 wide. So they're only 6 each. And the 1s on top didn't change, so we got 2 of those. Does that make more sense now?
Yeah.
Jason?
I wrote it out as 6 squared plus 12 plus 2.
Yes, but simplify it. You got to keep going. You wouldn't leave it written as 6 squared plus 12 plus 2. You'd add things together. Do the squaring of 6, because 6 squared is 36. Like all that math we can do. So we would do it. And then perimeter. Anyone got it for me? Natalie?
Should I explain how I got it?
You can just give it to me first.
Okay, it's
32.
30.
Do we have verification for that? Back it up, my other hands that were up. So we have 6, 7, 8 on the bottom now. Right? 7s on the sides. The extra 1s, and then the 6 across the middle. Brennan, what's up? Ooh.
24 plus 8 equals 32.
So if we look at, here's an x, here's an x, here's an x, and here's an x for my lengths. 6 times 4, right? I had 4 of the equation we already had. You already had written out 4x plus 8, or sorry. Yeah, so really I would write this the other way. Sorry, how you said it, I then wrote it backwards. I would normally do 4 times my edge length, now we know, of 6, then plus the 8. That's how I would write it. Just because this was x, that was the thing we didn't know. So that's what I would put in parentheses. Questions? If we jump down to C, because it's mildly different, let's keep using cards. Sorry, I just did that. Alana, what do we get for C's area? 15. So we have 6 in here, 6 in here, and then 1, 1, 1. totally agree.
Oh, 15. Yay! Gucci. I don't know.
Then don't. That's impulse control. Exactly what I talked about at the beginning of class. No, there's no, it's, just don't. Then perimeter, as we walk all the way around. What was our expression that we had for perimeter? Like before. What was it? 4x plus 8. So it was the same perimeter. So actually this is still going to be 32. And we can check it. We're going to walk all the way around. I'm not saying we have to. I'm just saying we can't. Questions? Now this is where your brain's going to get broken. Now x. We even go to the office. If you really don't want to be in my class, I just don't need a complainer in the middle of the room all class period. Now x is going to be a half. So why this breaks our brains, this square is now smaller, of course mine always sink to the very bottom, than this square. This square is smaller than this square.
Wow.
You have not lost your power to imagine, I'm sure. So in your head, you can imagine shrink this guy down to only lengths of 1/2 by 1/2. Okay, because this is 1 by 1, the new one has to be smaller. Go back through ABC with x being a half. Yeah.
This area thing.
So now that it's plus 5, 1/2 to the 14, that times 2. Layla? Let's stop pointing. Do it this out. You're silly. 2 times 1/2. Mr.
Labeling this almost makes things worse, but I have to, because I can't think about it any other way.
Oh, we have 6 equals x. Wait, what?
No, now x is a half, Diva.
What?
We moved on.
Okay, so we have to put that down. Well, I thought you
At some point, there's an E tool that we can actually like stretch things and look at it.
Whatever, I'm still working on the 1x pal you can stretch.
All right, so we're running out of time, so I wish I could give you more time. I really wish that my math class was like an hour so you had plenty of time to work. If we label, now area is going to be kind of weird, so I want to talk about that to make sure we get there before we run out of time. Area of a 1/2 square. It's 1/2 wide, 1/2 tall. What's a half times a half? A fourth. So the area in there is a fourth. What's the area of this rectangle over here? 1/2, right? It's 1/2 by 1. Thank you. Someone's awake. What's the area over here? Same, right? 1/2 by 1. And then 1 up there, 1 up there. So I have 2, 3 if I combine the halves, and a fourth. My area becomes 3 and 1/4. And then we could label that units squared if we wanted to clean that up. Perimeter. Now, even though we're not talking like terms or non-like terms, look for things that are the same. Grab every half first. How many halves do we have? 4, right? 1, 2, 3, 4. Yeah, 4 halves makes 2. And then 1, 2, 3. We already knew the 8. So our perimeter, 2 plus 8, we get 10. Now, if I were to actually try and draw this, the 1 tiles are big, like these are bigger than even this square in the middle. All right, so in Desmos, in CPM, if the homework gives you like a Desmos activity, you can probably click it and go play with like actually changing the size of stuff. So that might help your brain. That's all the time we really have for today. Mini mastery tomorrow. Study what we talked about earlier if you don't know it. Put your tiles away, please. What do you think about the quiz?
I think it's good. Did you already make copies?
No, I'm actually spaced out a little bit more.